all electrical circuits should be fused, right? Well, that's not quite the case anymore. Vehicle manufacturers are turning to current limiting technology, which effectively reduces the need for a fused circuit. This has the advantage of lowering manufacturing costs, reducing vehicle weight, and allowing for software diagnostic applications to be more effective. One such circuit where this is occurring is in the brake lamps, which are designed to provide a warning to other drivers that the vehicle in question is in the process of slowing down. If a fuse for these were to fail, then the stop lamps would be inoperative. This fault is generally not noticed by the driver of the vehicle until that car is presented for regular service and maintenance, or as part of a safety inspection. Current limiting technology allows a control module to detect a short in a brake light circuit and then turn that circuit off. If the cause for the excess current draw were to disappear, the control module turns the circuit back on without technician or driver intervention. This is how it works. Whenever voltage is initially supplied to a load, then the load, based on its resistance, will draw a known amount of current. This initial draw is known as inrush or startup current that the load needs to begin its operation. However, shortly after the load is turned on, the current level will begin to drop. This is due to the flow overcoming the initial resistance in the circuit. As the resistance decreases, then the current will proportionally begin to increase again until the forces within the circuit have stabilised. If a conventional fused circuit were to experience a substantial increase in current flow or an excessively large surge, then this will result in an open fuse. The current flow stops and any resultant damage is prevented. A control module with current limiting technology will approach the same problem a little different. When this type of circuit is switched on and inrush current peaks, the module recognises this for what it is, in essence, normal circuit operation. If at any point the control module detects a substantial increase in current flow or a surge that falls outside normal parameters, it then determines what course of action is appropriate. This might be simply switching the circuit off for a few seconds to let it cool. It may decide that the current draw is not great enough to cause damage and just log a fault code. Or it may isolate that circuit completely and substitute a known operating one instead. The control module performs this action through monitoring and control of current flow and is known as surge current regulation, or more easily recognisable as crowbar limiting. It's called this because the shape of the waveform closely resembles a crowbar. As seen in this waveform, current flow in a circuit should remain relatively stable. If a fault was to occur that caused the current to spike, or the duration of the surge is excessive, the control circuit will immediately reduce or limit the current flow to a safe level. This reduction is the current limiting phase of the control circuit. It's much more desirable than using a fuse that will simply open or blow, as the circuit is still complete and therefore may still operate if the fault is intermittent. The control circuitry for current limiting is housed within the module and is designed as part of the output driver. This way, the module is safe from downstream shorts and the circuit wiring is protected from excess current flow. Not only is the circuit still operational, but with this technology, fault monitoring is more precise, therefore making diagnosis relatively simple. This type of control and monitoring system has also paved the way to integrate bulb substitution technology if a brake light circuit fails. Bulb substitution is a method whereby all bulbs in the same housing, such as brake and tail lights, are of the same wattage. To differentiate between the brightness of each bulb, pulse width modulation is used. This basically means that a 21 watt bulb is pulsed at a 25% duty cycle, so its output reflects that of a 5 watt bulb. The brake bulb receives a 100% duty cycle, so it remains the brighter of the two. If a fault is detected in the brake light circuit due to opens, excess resistance or shorts, the control module can transfer the brake output signal to the tail light circuit. The tail light is then pulsed at a 100% duty cycle, and the bulb output is identical to that of the brake. The control module will send a message via bus to the instrument cluster, whereby fault notification can be made to the driver. My earlier statement about less fused circuits is correct. Although, keep in mind, there are still fuses allocated to the control module that supply current to each subcomponent. Although, these are there to protect the uphill side of the control module only. The next time you service or repair a vehicle, take the time to inspect which circuits are fused and which are current limited. You might be surprised at what you find. As always, keep training. Thanks for watching.